Okay, so let's put in practice what we were just talking about and see if we can do some examples of finding limits as I go to positive and negative infinity. So let's look at the following. Let's say that f of x is equal to 8x cubed minus x squared. This is in the numerator. So then we're going to put that all over the following: 7 plus 11x, and then minus 4x to the fourth. So a couple different ways that we can approach this. And it asks us to find any horizontal asymptotes. So there'd only be one. So find the horizontal asymptote if it exists. Can't write. So one way we can do it is what we had done in algebra. And we looked at the degree of the numerator and degree of denominator. So degree of the numerator was the largest power, which is 3. And then we looked at the degree of the denominator. So the largest power of our variable here is 4. We looked at which one was larger, and depending on which one was larger, or if they were the same, depended on if we had an asymptote or not. This one is larger in the denominator. So remember, if the degree of the denominator was larger, then it was at y equals 0. So we have a horizontal asymptote at y equals 0. The other way that you can approach this is to manipulate this. And we can manipulate this by looking at the degree of the denominator and multiplying by a fancy 1. And that fancy 1 is going to be 1 over the variable you're using raised to that highest, the degree of the denominator, that highest power. So if I looked at this, my degree of my denominator, right, is 4. So I want to multiply by a fancy 1. And that fancy 1 I'm going to choose is 1 over the variable raised to the highest power in the denominator. So x to the 4th in this case. So 1 over x to the 4th. Or another way to think of it is basically you're dividing each term in the numerator, each term in the denominator by that variable raised to the highest power that's down here in the denominator. And so if we do that, we have 8x cubed all over x to the 4th minus x squared all over x to the 4th divided by 7 divided by x to the 4th plus 11x divided by x to the 4th minus 4x to the 4th divided by x to the 4th. So we're going to now use our rules of exponents. So really quick, rules of exponents. If you have the same base, which we do, our base is x, and there's division, b to the m divided by b to the n, single term divided by a single term, same base. This is the same thing as taking the exponent in the numerator minus the exponent in the denominator. So if we do that, or I tend to do it this way. if my degree in the denominator is larger, I tend to keep it down in the denominator. And notice our degree in the denominator is always going to be larger. So another way, and really what we're doing is, recall if you have a negative exponent, it's in the numerator, we bring it down to the denominator to make it positive. Or if we had 1 over b raised to a negative exponent, we bring it up to the numerator to make it positive. So in this case, we could also write this b over m divided by b over n could be 1 over b, the degree in the denominator, minus the degree in the numerator. So let's use that fact when we're doing these. If we can simplify. So 8x cubed over x to the 4th. Well, degree in the denominator, 4 minus 3 gives me 1. So this is going to leave me with 8 all over x to the 1st power. Minus, same base, exponent in the denominator is larger, so let's just subtract it. So 4 minus 2 is 2. So this would be 1 over x squared. All over, nothing cancels for the first term in the denominator. So here I have plus 11. So our exponent of this x is 1. So the exponent on the bottom is 4. 4 minus 1 is 3. So we have x cubed in the denominator. Minus 4. And then x to the 4th over x to the 4th. Those cancel, leaving you with 1. So 4 over 1, which I don't have to write. And so now if I look at this limit, as x is going to infinity of this function, let's write it this way. 8 over x minus 1 over x squared all over 7 over x to the 4th plus 11 over x cubed plus 4. Oops, that's a minus 4. And we use that fact that we just said, if we have a limit, we have some number over x raised to the nth power, and that x value is going to infinity or negative infinity. And n was a positive exponent down here. We said that this goes to 0. So we're going to use this fact, our rules and laws of limits. So we can break it down as a limit of the first term in the numerator minus the limit of the second term in the numerator divided by the limit of the first term in the denominator plus or minus, etc., of the terms in the denominator. So every time I see a number over x raised to some power and that x value is going to infinity, I know that whole piece is going to 0. So 8 over x as x goes to infinity goes to 0. 1 over x squared as x goes to infinity also goes to 0. 7 over x to the 4th as x goes to infinity goes to 0. And 11 over x cubed as x goes to infinity goes to 0. The only piece that's left is this a minus 4. The limit of a constant, remember, is just that constant. And so if we break this down like this, we have 0 left in the numerator, all over 0 plus 0 minus 4. We're okay to have 0 in the numerator and not in the denominator. If it's not also in the denominator, this is equal to 0. Okay, so that limit I can see, or the end behaviors, our horizontal asymptote is at y equals 0. Okay, so this is where this rule right here, dividing by the variable raised to the highest power in the denominator, can be helpful when we do an example with a radical. So let me do an example with a radical. Now we have the tools to look at it and work with it. before I move that. Any questions?